Hello, friends, and welcome to this session of SelfReflex, wherein we would be talking about big data architecture. And the reason we are talking about this chapter is that I'm getting a lot of emails from different people and different groups where they want to understand that what is actually big data architecture, how do they actually solve the problems. Like everyone talks about Hadoop, HDFS, but how do we actually implement HDFS use cases or HDFS as a technology stack into the uh, solving the real data problems? So if you look at by and large, there are three modules that are involved in solving the big data problem. The first one comes out to be collector. The second one is analytics engine, and third one is publisher. Yes, there are multiple components involved within the collector, analytics engine, and publisher. But if you look at it very high level, then these are the three modules which are mandatory if you are trying to solve a problem for the big data space. Now, if we deep dive and want to look at what is collector, then collector is basically used to receive data from all the sources. So imagine that you are trying to solve a problem for uh, analyzing that how did the student of class 10th did all over in India based on their states, district, gender, subject, and a different permutation combination of these things. How do you solve it? Then the very first thing would be you want to receive data from CBSC, let's say, for all the subjects, for all the students. Then you would also like to have some data which can give you information about students' demographics and students' geography, as in where they are, what is their gender, to which school they belong to. This data can come from CBSE or from different schools. We will not go into that detail, but understand that these data are required to solve this use case. Then, how can you receive this data? This data can come as a file-based data, or it can become as streaming data over a UDP or a TCP socket. Generally, UDP socket is preferred because it is less costly, and given the data is coming at very high velocity and high volume, you would like to use UDP to get not to bring the TCP overheads. Some data can be quasi-static data. Now, what do you mean by quasi-static? Quasi-static is which is moving but at a slow pace. In the use case that I talked about recently, we don't I don't see that there would be a quasi-static data, and this all data should come once every year, like in 2016 for CBSE exams, and in 2017 and in 2018. Then what do you do on top of this data? On top of this data, I expect that data would not be coming only those fields that are required by you, but there would be certain noise present in that data. Then you need to filter out that noise from actual data. Otherwise, you would be storing large chunks of data, which does not make sense, and unnecessarily increasing your read write times and storage and whatnot. Then you would like to compress that data so that this data can be stored in lesser space and takes lesser read and write IOPS, because compression is generally in memory thing. This data is mostly written in HDFS, and the reason it is written in HDFS because and I know most of you have answered that because of the distributed fashion. On each node, this data is available to be read, and it gives us high performance and all the benefits of HDFS. Okay. Now, what is an analytics engine? So until now, what we have done, we have collected all the data from all the sources and filtered it, and the required fields that are mandatory for us in the use case, they are present in the HDFS. Now, on top of it, there should be some engine which does the converts the business logic, which is your given by your product managers or program managers, to convert them into your technical logic, which can be that you need to join various teams, you need to map certain data from by doing a key pair value lookup into another field. Then there can be certain machine learning algorithms that might be required, and these machine learning algorithms might be are required to find the, let's say, pattern, that how did the girls of Delhi perform on top of girls of Chennai, or how did the boys of Calcutta perform over the boys of Mumbai. So in order to find these patterns, these uh, trends, some learning algorithms might be required, and they are best used in analytics engine. Now, you might be wondering that recently I was talking about that you want to convert your business logic into technical logic, but what I'm saying that you're transforming technical fields into business fields. So, see, understand the difference. The difference is in first one, the business logic was how did the different states student performed in mathematics and which state came out to be the topmost. So if you club all the data in different states and then uh, do the sort and find the top three states, then you will get the number of the you will get the uh, number of students in each state with their average marks in mathematics, and then probably you can find out that in mathematics what was the who which all states did the best. Or the other logic can be that in terms of the number of the percentage of students who passed in mathematics from every state, then you can select the top three states. So it is totally a business logic that what is the definition of finding top states with respect to mathematics. Okay. Now, essentially, when you are converting this business logic into a technical logic, you would be doing some sort, you would be doing some averages, you would be doing some filtering, and then finding the top three states, and you would say state one, subject one, uh, and let's say um, total number of marks. But how do you eventually translate into the business field? These fields that we just talked about, they need to represent each state. So you will not be using when you're optimizing your code, you will not be using states like the full name. For example, uh, Uttar Pradesh, Arunachal Pradesh. These are very long strings. I'm assuming that you would be using certain uh, IDs associated with these states in order to reduce the sort and shuffle time, and then you would be translating these IDs into the real names on the publisher. But being publisher being uh, so by and large, you should not put these logic in publisher. So these technical fields, while you are writing into the final cube, would be converted into the business field by the analytics engine. Then certain aggregation group by, like we were just talking about, that how would you convert the business logic into the technical logic? You would call some grouping, some sorting, and then you would aggregate the data, because it does not make sense that, let's say, there are 12 lakh students who does the class 10th result every year. You keep the data of all the 12 lakh students every time. You may want to, but probably not as the output of analytics engine, but as a substrate of analytics engine, or probably as an input of the as the output of the collector. Then this data is mostly compressed and used in some form of columnar database to balance between the performance and the complexity to serve the publisher. Of course, this data is also mostly written in HDFS, and the reasons are like to gain the advantage of the Hadoop and the HDFS framework. Now, what is a publisher? So publisher is basically, can be any uh, a lightweight web server which can be used to publish data on a UI. This UI can be your homemade UI, or it can be freely available to tools like Splunk, Tableau, and you can also provide some REST APIs in place of UI if that's a use case. Like uh, we don't want to have our UI, but there can be certain APIs which can be plugged by different schools or education boards to find out the data, or there can be certain PDFs and CSV reports which are used by the management, the ministers, and those use cases. By and large, we do not put business logics in publisher, and the reason is publisher is supposed to be lightweight. All the heavy lifting is done in analytics engine. Okay, so guys, this is a very high level overview of your big data architecture and the block diagram, that how do you do it. Please stay tuned to our YouTube channel, wherein we would be soon publishing the big data architecture as a deep dive, wherein we would also talk about each functional that I just talked about with its corresponding technology component. And we would also pick one use case, the student's use case we were just talking about, and we would directly uh, map that how do you actually translate that data from one form to another, and how do you actually publish that data on UI. Thank you.